Right, we're going to finish up the 1.1 practice on this. So this is the opposite domain and range. Okay, so domain, remember, is x, range is all my y's. So it's going from negative infinity to infinity on my x. The lowest it shall go is negative 6, and then it keeps going up. So if the lowest it goes is negative 6, it is included. So I'm going to put a closed dot, and I know it needs to go up and to the right and somehow up and to the left and be a function. Okay, so that means it passes my vertical line test. My next one, the furthest over it will go is negative infinity, and it should stop at 2. The lowest it goes is 0, and the highest it should go is 6. Okay, so at 2 it should be a closed dot, and then we also have 0 and 6 in here. The other thing is it's not a function, so that means when I do it, it can't pass my vertical line test. Okay, so if I wanted to do a closed dot at 2, I know 0 and 6 also have to have closed dots, so if I wanted to, I could put closed dots on them, which would make it automatically not pass my vertical line test when I traced them over, and then it needs to keep going to the left. Okay, because I have two x values, it would not make it a function. Okay, if it was trying to be a function, you could have placed the 0 dot over here, okay, because it's still on 0 technically. Okay, my next one here is a little tricky. So I started off at 0 and it goes to positive infinity. It also comes from negative infinity and goes to 0. So the furthest left it's going to go is going to be 0. Then it needs to shoot off to the right and downward. So I'm going to do a closed dot. It needs to shoot off to the right and downward. That's what my right arrow meant and down arrow meant. Okay, my next two, it goes from negative 10 to 2, and then negative 2 to 4. These are matching, so I'm going to go ahead and make a point there. And then I need to somehow get a closed dot, or an open dot at 2, and a closed dot at 4. That was supposed to be a 4. And then it is a function, so it needs to pass my vertical line test, so if I just wanted to connect them, I'm good to go. My next one, it's going from negative 1 to positive infinity, and then it needs to go up and down. Okay, so I know it is a closed dot because it's a bracket at negative 1. I need to go up and down, and everything needs to be going to the right. So if I'm going upward and downward, that would also not be a function because it wouldn't pass my vertical line test. So you just got to follow your lines to the arrows that you've drawn. Okay, this next one's pretty tricky. So it's going from negative 4 to 3. The highest it will go ever is 2. It's not going to move up. It's not going to move down. Okay, so I know it's a closed dot at 3. So I'm going to put my closed dot at 3 because it can't go any higher than that y equals 2. It needs to be an open dot at negative 4. Can't go any higher than that y equals 2. And then it cannot equal 0. So I'm going to put an open dot when it hits that 0 mark. And it can't go any higher or any lower than 2. Okay, parent functions, behavior, maximum, and minimum. So we're going to start 1.2 now. So if we're just filling in all the functions, this is going to be a, let me zoom in here, quadratic. Okay, or it's also called a parabola. My next one here is going to be a rational function. You might hear me say hyperbola. It's mostly going to be called a rational. So my quadratic, remember, always makes the U shape. My hyperbolas will make a like W. Okay, the next one is an exponential. So you might hear with exponentials talking about money, exponential growth. Hopefully you will be increasing your money, so it should look like that. We then have our linear equation, so it's going to look like a line like this. Okay, we have our cube root and our cubic. So cube root and cubic because it's being cubed. Okay, so my cube root equation will look like this. And then my cube root equation, yes. And then my cubic equation is just the same thing turned. Okay, my next one is absolute value. and it's going to be a V shape on your graph. And my last one is a square root. And because we can't have any negatives under our square root, it's going to shoot off to the side. Okay, x and y intercepts. So x-intercept we might call as zeros or roots. It's basically where the graph crosses the x-axis. So highlight or underline that. The y-intercept then is where it crosses the y-axis. The reason we say intercept is because we're intercepting that x-axis. We are intercepting that y-axis. There might be multiple ones, so realize that. Label both the x and y intercepts. So we have x, y-intercept. Okay, it looks like we have an x-intercept here and a y-intercept here, so there could be multiple ones. Okay, maximum and minimum points. So maximum is my high point. Minimum is my low points. Okay, so if I were to have a picture that looks like this, this would be my maximum, my high point. This would be my minimum, my low point. Turning point is also referred to as degree. So basically, whenever your graph turns, so if I can draw a picture here, there is one turning point here. So it changes direction a little bit. Okay, it's also called degree, how many turns you have. Okay, so in this we're labeling our max and min. So here is my max, here is my min, and there are two turning points, so it's a degree of 2. But we actually have to add 1 to that, so my degree is 3. When I throw equations at you, it will make a lot more sense. Okay, my next one here, we have a minimum, and it's going to be a degree of 2. Okay, because that's a squared graph, x squared graph, that's why the degree is 2. This is actually a cubed graph, which is why the degree is actually 3. End behavior, this is talking about what's happening to the left of the graph, to the right of the graph. So you'll see it's supposed to have arrows here. Oops. I'm just going to rewrite it. X approaches negative infinity, f of x approaches positive infinity. Okay, so f of x basically stands for y. So whenever you see f of x or g of x or anything like that, it stands for your y. So when I'm looking at a graph, this positive means what is happening to the end behavior to the right of the graph. So what's happening to your graph to the right side. This negative means what's happening on the left side of it. So over here on your x. Okay, this is just y value. So what is that end behavior doing? Is it going up or is it going down? Okay, so if we look, this means my positive side of my graph. So what is happening to the right side of my graph, it is going up on my y-axis to positive infinity. Okay, negative infinity means what's happening on the left side of my graph. It's going to positive infinity again, up on my y-axis. So we're going to do positive infinity. Then it also wants us to state our domain and range. So it goes, domain is all my x values, so it goes to negative infinity to positive infinity, so all real numbers. The lowest it goes, we're going to just say that's at -4, and it includes it, and it goes up to positive infinity because it never ends on my y going upward. Okay, my next one, I'm just going to erase this and use the same thing. Okay, so as x is on the right side of my graph, it is going upwards to positive infinity. This means the left side of my graph, it is going downwards, so negative infinity. Okay, if we do our domain and range, my domain is on my x value, so it looks like it's going from negative infinity to infinity, so we're good with that. The lowest it goes on my graph for my range, on my y-axis, it goes to negative infinity to positive infinity again. It's almost like a straight line. So straight lines, remember, are all real numbers. It never stops anywhere. It just keeps going. Okay, if I go down here, as x approaches positive infinity, so my right side of my graph, as x approaches negative infinity, or the left side of my graph. So the right side of my graph, it's going down, so negative infinity. The left side of my graph, it is going down, so negative infinity. We're doing domain and range again. So domain, it looks like it is going leftward and it's also going rightward. So we have all real numbers again. It never stops. Okay, my next one, the lowest it goes is negative infinity for my range. And the highest it hits at is 4. And since it hits at 4, it's going to be a bracket. Okay, if we do our last one over here, so I'm just going to erase these and use them. Okay, the right side of my graph is going to negative infinity. The left side of my graph is going to positive infinity. My domain, it's going left and right, so it's going to be all real numbers for my x. It never hits a low because technically this keeps going forever and ever. It also never hits a high because this keeps going forever and ever. So that's a tricky one, that it's all real numbers.